Hi everyone, in this video we're going to be looking at how to graph sine and cosine. So the first thing we're going to do is we're going to go ahead and look at a review of how to graph a line from algebra. So let's suppose we have the equation y equals 3x minus 2. So to graph the equation y equals 3x minus 2, usually what we do, there are of course advanced methods of how to graph this type of equation, but the most basic idea here is that we just want to plug in numbers for x and then get the values for y. So usually we would make a table of values. We would have x and y values here like this, and then we just pick some numbers for x and then we plug them in. So let's suppose we pick the numbers -2, -1, 0, 1, and 2. So if we plug those in for x, so if I plug in x equals -2 into this equation here, we're going to get -6 minus 4, and that's going to be -10. And first of all, why is it -6 minus 4? I don't know, but it should be, if it's -2, should be -6 minus 2, that gives us -8. Alright, now let's plug in -1. So if we plug in -1, it's going to be -3 minus 2, -5. Okay, if we plug in 0, and then 3 times 0 is going to be 0, and then minus 2 will be -2. And if we plug in 1, then we get 3 times 1 is 3, and then 3 minus 2 will be 1. And if we plug in 2, then 3 times 2 will be 6, and then 6 minus 2 will be 4. So once we feel confident that we have enough points, we're going to go ahead and now make a x and y xy axis, also called the rectangular plane. We're going to label the axis. And then do the same thing with the x values. Now I'm instantly regretting my choice of scale here, but so what we're gonna have to do here on the y-axis is go by 2s, or we can go by 1s, but like in between here it'll be we'll see. Alright, so what do I have so far? So this would be -1, -2, -3, -4, -5, -6, -7, -8. So that technically is enough there. And so I don't clutter it too much. I'm just going to label the evens. Alright. And then do the same thing with the positive values here. Okay, so we have 2, 4, 6, and 8. Alright, now let's plot our points. So we're going to plot -2. So we have to go left 2 and then down 8. So we're going to plot our point right there. -1, 5. So -1 and then down 5 to right here. 0, -2. So 0, -2 right here. 1, 1. 1, 1. So right 1, up 1. And then the last point is 2, 4. So right 2, up 4. So if you remember from algebra, this is what we call a linear equation, because the graph that we get out of it is a line. So now we just connect these with a line, and we're done. Alright. So that's the idea of graphing an equation. You just pick numbers for your x, and then you plug them in, and then you get the y value, and then you plot your ordered pairs that you get here. Let's start with y equals sine. So y equals sine x. And what we're going to be doing here is we're going to be, once again, picking numbers for x, and then getting values for y. Now, intuitively here, the values that you're choosing for x are going to be angles. So in terms of the things that we plug into our trigonometric functions are the same types of quantities. So we're plugging in angles, and then the output is going to be the ratios. All right, so if one wanted to, one could pick, so let's suppose we get our x and y chart. Usually what I like to do in the beginning when we're learning this for the first time is I like to pick I like to start at 0. And we always use radians because the x and y plane are real numbers. You only plot real numbers on the x and y plane. So it doesn't really make sense to plot degree measures on the x-axis there, or the y-axis. So we're starting off with 0, and then we want to pick some other values to choose here. Now, to help us out, what we can do is the following. We can grab our trusty unit circle. Now, here's my unit circle, and I'm going to be using this just to compute the values of my trigonometric functions. Now, remember that if you're using the unit circle and we're graphing sine, remember that sine on the unit circle, sine of some angle is equal to the y-coordinate on the unit circle. I don't want you to confuse this with the y value, even though it will seem like they're the same. But I don't want you to confuse this y value with this y value. Alright, so they are technically two different things. We're only using unit circle here to find the value of y over here. So hopefully this all makes sense in a second. So what we're doing is we're picking values of x, and so for example we're going to pick angle measures. Let me just give you a preview here of what's going on. So let's say this is your x-axis, right? So you're going to be choosing these values here to plug in here, right? So in terms of your x-axis, the x-axis you're going to start at 0, just like when back up here in this other graph we have this x-axis here, and numbers to the right are our positive values and numbers to the left are our negative values, right? Same thing here. So the values to the right are going to be our positive values, and to the left of 0 is going to be our negative values. What does that mean in terms of the unit circle? Okay, so to the right we have positive angles. And how do we generate a positive angle? Well, we go around the unit circle clockwise, or counterclockwise, right? So we move around the unit circle going counterclockwise, and that generates our positive angles. So all of those angles that we generate by going counterclockwise are going to be on this side. What if we wanted the negative angles? Well, in order to get the negative angles, what we would have to do then is go around the unit circle clockwise. And that would give us negative measures, because that's how we find negative angles. We go clockwise when we rotate. So we're going to be, for now, we're going to just be using positive values, and I'll talk about the negative values after we're finished with these positive values. But for now, we're going to be starting here at 0 radians, and then we're going to be increasing the angle going this way counterclockwise. I'm not going to be picking every single value that's here. That would be kind of overkill. If you really wanted to make your graph a little bit more detailed, you can certainly do that. You can certainly pick more points, and maybe by picking more points you'll kind of really grasp the idea here. But really all we need is just the general shape of the curve. What I'm going to pick here is I'm going to pick pi over 6. I'm going to pick pi over 2. I'm going to pick 5 pi over 6 pi. All right, the next one is going to be 7 pi over 6, 3 pi over 2, and then I'm going to pick 11 pi over 6, and then 2 pi. So notice all I'm doing here is I'm starting off at 0, of course, then pi over 6, and then pi over 2, and then 5 pi over 6, and then pi, and then 7 pi over 6, and then 3 pi over 2, 11 pi over 6, and 2 pi. So I'm picking some sample points in each quadrant along with the quadrantal angles just to give me an idea of what the shape of the graph is going to look like. Now, why did I pick these numbers? Well, I picked these numbers because if we take a look at what pi over 6 corresponds to, remember that sine is equal to the y value. The pi over 6 for sine is going to correspond to 1/2. And 5 pi over 6 also corresponds to 1/2. 7 pi over 6 also corresponds to 1/2, but this time it's going to be negative. 11 pi over 6, same thing, corresponds to 1/2, but now it's negative. And so the reason why I chose those multiples of pi over 6 there is because the value of sine is an easy number to work with. It's 1/2. Versus like pi over 3 is going to be root 3 over 2. Now I got to use a calculator to approximate the value. And same thing with pi over 4. You have to use a calculator. You're going to get root 2 over 2. You got to use a calculator to approximate. So I'm only using these multiples of pi over 6 just because they're just easier to work with. So now what we're going to do is we're going to plug these numbers in. So now I'm going to find the sine of 0. So find the sine of 0. And remember, what we're doing is, if we're using our unit circle, we're at 0 radians. Let me zoom in on that. So we're at 0 radians, and then we're just simply reading off the y value at that coordinate. So here the y value is 0. Therefore, the sine of 0 is 0. Okay, moving along at pi over 6. So if I were to plug in pi over 6, so the sine of pi over 6. So you see we're doing the same thing. We're taking our x value, we're plugging that in, and then we're computing that to find the value of y. So same thing as what was happening up here. All right, so let's keep going. So sine of pi over 6, okay, so at pi over 6, the y value is 1/2. So here this is going to equal 1/2. Okay, keep going. Sine of pi over 2. All right, so at pi over 2, the y value is 1, so we get 1. At 5 pi over 6 now. All right, so at 5 pi over 6, we get the y value being 1/2, so it's 1/2. All right, sine of pi. Okay, so now we're here. And this time the y value is 0, so therefore the sine of pi is 0. 7 pi over 6. All right, so we're at 7 pi over 6. And here the y value is -1/2. And 3 pi over 2. All right, so at 3 pi over 2, here's 3 pi over 2. And then the y value is -1. And 11 pi over 6. Okay, so we plug that in, and we get that at 11 pi over 6, our y value is -1/2. And then now at 2 pi, we're all the way back around at 0. So 2 pi is the same thing as 0, and then the y value there is 0 again. Oops. All right, so now we have our graph for, now we have our points for sine. So now we're ready to plot them and see if we can recognize any kind of shape, or at least pick out a shape once we plot these points. All right, so now once we have our table created, now we're going to make our x and y axis. So we have our x and y axis. Oops. And now we're going to label the x-axis. When we label the x-axis, what I like to do is I like to evenly space out 4 tick marks along the axis here. Okay, so I'm still going to space it that way. So I'm going to divide this into 4 equal pieces. And these 4 equal pieces here are going to correspond to our quadrantal angles. So for example, the first one, of course, here at the very beginning is going to be 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And now I'm going to label my other angles, the pi over 6's. Now as I do this, I just wanted to bring back the unit circle here really quick, just so that you can kind of see the proximity in terms of how to space out where these angles are going to be. So let's take a look at pi over 6. If you look at pi over 6, here's 0 and here's pi over 2. That's going to be what this distance is here between these 2 points, 0 and pi over 2. Now if we look at pi over 6 is right here. And if we look at which angle it's closest to, is it closer to 0 or is it closer to pi over 2? Well, it's closer to 0. So when I plot that on my number line here, I'm just going to indicate here that it's a little bit closer to 0. Maybe that's being a little bit too generous, but I'm just going to put it there like that. All right, moving along, the next one I need to plot on here is going to be 5 pi over 6. So where's 5 pi over 6? Well, 5 pi over 6 is right here. It's between pi and pi over 2. So that's going to be in between here. And which one is it closer to? Well, it's closer to pi. Right. So when I label this here, I'm going to put it closer to pi. So this will be 5 pi over 6. And now let's move on to 7 pi over 6. Okay, so 7 pi over 6 is here. 7 pi over 6 is between pi and 3 pi over 2. And so on my axis here, it's going to be between these two. And if you look at that, it's closer to pi than it is to 3 pi over 2. So let's go ahead and make sure we indicate that here. So we'll put it like right here, 7 pi over 6. And let's move on to the last angle, 11 pi over 6. So 11 pi over 6 is right here. It's between 2 pi and 3 pi over 2, which is this piece on the x-axis here. And it's closer to 2 pi than it is to 3 pi over 2. So we're going to put it like right about here, 11 pi over 6. And there you go. So another thing that I wanted to show you, and let's see if this will allow me to do it. Maybe it will. Okay, so let's see what happens. All right, so what I'm going to do is I just want to show you that in terms of when we label things, you know, like how when we label things as like 1, 2, 3, 4, 5, and so on, I just want you to understand as well that the pi over 6 is a number. It's a decimal number. And all of these decimal numbers here that we are labeling on the x-axis are in order. So if I look at pi over 6, so if I do pi, oops. Okay, maybe it's not going to show it because it might be off the screen, but maybe I can bring it down just enough here. So if I divide that by 6, that is equal to, there you go, you can see it there. That is equal to 0.5235 as a decimal number. And then if we do pi over 2, so if I did shift pi over 2 here, and then we see that that decimal number is increasing. Now it's at 1.57. And, you know, in terms of like, you know, 0, 1, 2, 3, you know, that would be the decimal 1.570. And if I did, let's say 5 pi divided by 6, 2.61, and I'm showing you that because that was the next number. Oops. That would be the next number that would be plotted there on the x-axis. Okay, now with all of these points, the next thing that I want to do is now we're going to plot the y values for these points. And so what we're going to do, this might not be to scale, but let's suppose this is negative a half. Let's say that's 1. Let's say, or that's positive a half, negative half. This is half. This is positive 1. So this is positive 1, this is negative 1, 1/2, negative half. Alright, so let's plot our points. So we said that at x equals 0, that y is 0. So therefore that's going to correspond to the origin. At pi over 6, the y value is 1/2. So we're going to go pi over 6 units to the right, and then 1/2 unit up, and then plot our point right there. At pi over 2, the value is 1. So we go right pi over 2 and then up 1. Alright, so just moving on now. Let's see what's next. At 5 pi over 6, so here's 5 pi over 6, and then it's positive 1/2. So, alright, so we go to 5 pi over 6 and then up positive half. And next at pi, now it's at 0. So, oops, too far. So, pi, alright, we go pi and then 0. And then at 7 pi over 6, now we're at negative half. So if we go over to 7 pi over 6, and then now we're down at negative half. Oops, let me adjust that. Should be like right here. And then 3 pi over 2, negative 1. Alright, and 11 pi over 6, negative 1/2. And then 2 pi, we're back at 0 again. Alright, so what you see here is the shape of the sine curve. You see this little peak here, and then it comes down to this little valley, and then we come back up. This is the typical shape, or the basic shape of our sine curve, and this is usually what we think about when we say sine. Y equals sine x. This is the curve that we think about. Alright, so now let's connect that. Okay. Alright, now this curve is going to repeat itself, because if we were to go around, now think about it, what we did was we went around the unit circle one time, and once we're at this point, we're technically back at this starting point, right? Because this point was where we started on the unit circle, and now at this point we're right back at that same position. So if we were to go back around again, then what would happen is that this shape right here would be traced out again here, and then this shape would be traced out, a little bit further down the line. Alright, so this curve just keeps continuing on forever. That's why if you've heard the term sine wave, it's because you have this curve that just kind of goes like this repeatedly. Okay. Now, what about for the negative angles? Well, the negative angles are generated by going backwards. So remember, this is the start of one cycle. This is the end of one cycle. So pretty much what's going to happen is that the angles, okay, let me bring up the diagram again. So here's our unit circle again. I just wanted to bring it back. And what you see here is that this half right here corresponded to this half, right? And then this half right here, let me let it die out. Okay. And then this half right here corresponded to this half, the bottom half. So the bottom half corresponds to the portion below the x-axis, and the upper half corresponds to the half that is above the x-axis here. All right. Now, if we were going to go clockwise, then we would be going here, and then we would be going along the bottom half. So for example, we would be doing, this would be negative pi over 6 right here. The 11 pi over 6 would be a negative pi over 6, a negative pi over 4, a negative pi over 3. This would be negative pi over 2 now. So if I were to label some of those values, you know, for example, you know, oops, let me do it like this. I would have like negative pi over 6. This would be negative pi over 2, and this would be like a negative 3 pi over 2. I don't want to label them all, but the point is now that as I'm going this way, since it's a bottom half of the unit circle, this is going to be a carbon copy of this bottom half. So this point right here is corresponding to this point right here. So therefore, what we are getting is that this half that's traced out here as we are going clockwise is going to be down here like this. So you get the sine curve, it would be something like this. Oops, let me do it like this. So you have something like this coming back up to 0 like that. And of course, as you continue to go around the unit circle, I'm off the screen over there, but as you continue to go around, you're going to get more of the curve. All right, and as you keep rotating and rotating, once again, you just keep getting, you know, the sine curve this way, and then you get more of the sine curve going towards the negative direction. All right, so as we continue on our deep dive of the sine function, I just wanted to also show you another neat little diagram or neat little, I think this is called like an applet or something like that, where it illustrates the unit circle and how that unit circle generates the graph of sine. So this right here is supposed to be your unit circle, and you see this point right here, that's supposed to be 0 radians, and that point right there corresponds to the origin on the x and y plane. And notice that these are the quadrantal angles labeled on the x-axis. So right over here in this little window, it has your A. The A is corresponding to the angle, I guess A for angle. And notice that it goes between 0 and 360, and I think that's just for programming. That's why they're labeling it like that. Now, as we start to increase the angle, notice that the graph of sine increases. Now, why is this happening? Another thing I want to point this out is, remember that the heights of the graph are the y values, right? So in terms of your y's over here on the sine graph, those values are based off the y value on the unit circle. So as we are going around the unit circle, let's come back. Oh, I messed it up. Hopefully I didn't mess it up. Let me go back. Okay, so we go back to 0. Now, notice that the height right now is 0, and so that's why it starts at y equals 0. But as we start to increase the angle, the y's increase, so the height of our sine graph over here starts to increase. So as we get to pi over 2, we reach a maximum height on the unit circle, right? At pi over 2, we have a maximum height of 1, right? Y is equal to 1. And then once we pass up that angle, we see that the angle starts to the y value starts to decrease. So as the angle increases to pi, the value of y starts to decrease. It gets smaller and smaller and smaller. And then once we get to pi, now it's at 0. Okay, now when we get to quadrants 3 and 4, we know that sine is negative in those two quadrants. So now even though the y is increasing in height, it's still negative, right? So it's increasing negatively. So as we see here, as we start going around, now the y's are now they're, you know, increasing negatively still. You see them getting bigger and bigger. And then we get to 3 pi over 2, where it reaches once again a maximum, or in this case, technically a minimum value, because that's the smallest it can be. And now we start, oops, that's not what I keep grabbing the wrong thing here. So now we rotate around, and we see that now as we go back to 0, the graph, the y's go back to 0, and so we get our sine curve. All right. Now, imagine like if this were 0 instead, and we were getting the negative angles. As you see here, keep doing the wrong thing. What do I get? Okay. All right, there we go, like that. So if I was going backwards, you see, we can see that as we rotate clockwise, you see as I'm going clockwise, you see how the graph is going this way. It's like it's just kind of reversing itself. So all of those negative values over here, that's how we generate that piece of the graph, by starting off at the end technically, and then kind of going this way with it instead, you see? Okay, I'm not doing that on purpose. I just literally just cannot remember that I'm not supposed to grab that part. I'm supposed to go over here. Anyway. Okay, so hopefully that kind of, you get that visual of how the unit circle can generate the sine graph. So what I want to do is just define a couple more things here, and then we'll wrap up the video. I think I'm already getting close to my time limit for this video. Looks like we're going to have to do two parts, one for sine and one for cosine, but I think the one for cosine will be a little bit faster because this is the ideas are pretty much the same as sine. Of course the graph looks different, but the ideas are the same, so we won't have to go into a lot of the details like we did here. But anyway, the other things I want to bring up are domain and range. Let's start with that. So domain. The domain of a function is the set of all x values that correspond to a point that is on the graph. And so if you look here, the domain is the x values. If you can remember that from algebra, these are the x values. So when I look at my x-axis, I ask myself, are there any x values that are not on the graph? And at first you might say yes, because you see that there's no graph over here, but remember we said that this graph keeps going forever, so it just keeps going. So I'm just kind of dashing it to indicate that, and then this piece would keep going this way. So it would never stop. So we would then say that since all of these x values, since all the x values are on the graph of the function, we would say that the domain of the function is all real numbers. And the way that we indicate that is by saying negative infinity to infinity. And we use parentheses here on the end just because infinity and negative infinity aren't numbers. And we use parentheses on expressions or quantities that we never attain, that we never take the value of. So because these are not really numbers, we can never really attain those numbers, so we're using parentheses here. All right. Now the range. The range is corresponding to all of the different y values on the graph. So if we look at the y values on the graph, look at our y-axis here. Here's our y-axis. Which y values are on the graph? Well, we can see that the y values that are between -1 and 1 are all on the graph, and everything outside of that region is not, right? So for example, -2 is not on the graph, right? So if we look at an imaginary line for -2, we see that that line never crosses the graph. That means that there's no x value that corresponds to that particular y value. So, but every number that is in between -1 and 1, if I drew an imaginary line for that, we see that it would intersect the graph. That means that there are x values that correspond to that y value that are on the graph. So we would say then that our range is going to be from -1 to 1. We always, anytime we list domain and range, it's always going to be smallest to biggest. And this time we attain these values, right? The points -1 and 1, the y values of -1 and 1, these numbers here are actually on the graph, right? So here we eventually attain those values. We can say we get it over here again, and then 1 over here again. So those values are attained. So what we do is those are now included. So to indicate that we are including these numbers in the range is we use brackets instead. So our range is going to be -1 to 1, and we are using brackets to indicate that those numbers are actually in the range. And then same thing here, bracket here, because 1 is in the range. Okay. Let's see. Another thing that I want to point out is something called the period. So the period of the graph is the length of one cycle. So how long does it take to repeat the shape of the graph, or how long is it until it starts to repeat again? So we see that the length that it takes for the graph to repeat itself is 2 pi units. So we say that the period of the sine function is 2 pi. Right, because that's the length of one complete cycle. All right. So now the last thing I want to talk about here is the amplitude. And the amplitude is the distance from your midline. In this case, it would be your midline would be the x-axis here, because you can see it divides the graph in half. And the amplitude is the distance from the midline to the peak, or the midline to the valley, or the minimum. So you can say the midline to the max or the midline to the min. So in this case, this distance here would be all the way up to the maximum value. How long is that distance? Well, that is 1 unit. How far is it from the max to the minimum value? Oops, to the minimum value. There it is. Well, that distance there would be 1 unit as well. So we say that the amplitude is 1. All right. I go into a little bit more detail in the lecture video for 4.1, but we do a lot of other things in 4.1. So the purpose of this video is to get a lot of the basics. I usually find that students get confused about just the basic graph and where do all these, how do we even generate the shape? How do we generate this? How do we label the x-axis? How do we plot points? How do we decide how to choose points? And so I wanted to, give a nice, long, detailed video about how this sine graph is generated. And I hope that this helps you. So if you have any questions regarding this video, feel free to stop by office hours.